Today we're going to build on the last two classes of factoring. Remember, factoring is unexpanding, it's unmultiplying, it's undoing the distributive property, it's undoing FOIL, it's undoing binomial expansion. Today we're going to learn about how to factor a trinomial. So recall a trinomial has three terms, and we're going to look at factoring trinomials of the form ax squared plus bx plus c, where a is the leading coefficient when we write the polynomial in descending powers of x, and a, b, and c are integers. So again, nice numbers for a, b, and c. Last class we looked at factoring polynomials of the form x squared plus 3x plus 2x plus 6. And we employed a method called 2 by 2 grouping. And we're going to continue with this today. Recall that we got a polynomial of this form when we multiplied two binomials. So again, what I'd suggest you do is go back and look at, again, binomial expansion. And what you will see is when we multiply two binomials, we get a polynomial with four terms. And as I say in my next note, if we're asked to expand two binomials, we would combine the like terms and we would end up with a trinomial most of the time. Sometimes we only get two terms. And this turns out to be a bit of a problem. So being a good student and combining like terms when you multiply turns out to be a little bit of a problem when we want to unmultiply. So let's look at an example and the problem that I'm talking about with a trinomial. So here's an example of a really simple trinomial. And if I were going to do my area model would have three parts to it. It'd have an x squared part, it would have a plus 8x part, and it would have a 12 part. And what I want to emphasize, as we did in the notes last day, well, by using the greatest common factor goes here. And what I want to emphasize here is there's not going to be a greatest common factor other than 1, and 1 is a useless factor. It is the only useless factor. Okay, if we looked at this exact same problem as we did 2 by 2 grouping, well, maybe this would help. And this is what I mean by the ish 2 by 2 grouping. 2 by 2, four terms. Now, the pattern that I've been really trying to emphasize is when you solve pictorially, we're going to put the x squared term here, we're going to put the number term here, and the things that go in here were our like terms. This is the 2 by 2-ish. So one of the things I can do is, if we initially, when we multiplied two binomials, we ended up with four terms, and again, we got to three terms by collecting like terms. Well, one of the things that causes us our little problem is that simple idea of combining like terms. So if we're going to solve this pictorially by making it look like a 2 by 2 problem, what we need to do is break apart that 8x. Now, there are an infinite amount of ways to break apart the 8x. So again, here's what we're going to need to do. We need to undo what we did before. We need to undo this idea of combining like terms. So we need to break apart the 8x into two pieces. But the problem with that is there are an infinite amount of two pieces that add up to 8x. So for instance, just some right off the top of my head, we can have x and 7x, we can have 2x and 6x, we can have 3x and 5x, we can have 4x and 4x, and I'm not even talking about, well, negative 1x and 9x and negative 2x and 10x and forever. that way. So I'm just going to play the devil's advocate right now, and I'm gonna kind of guess and check the answer. Now I don't want you to write this down, but I want you to notice something. So the little problem is, well, how did we originally, when we multiplied our two binomials, how did we originally get 8x? So I'm just going to make an assumption, and I'm going to assume, don't write this down, I'm going to assume that we did it this way. And if this was the right answer, if this was the right way to break apart 8x, then everything's going to work out nice. So I'm just going to go ahead and do this problem. I'm assume it's right, and we're going to see if it works out. So again, with our 2 by 2 method, the only way to get x squared is multiply x times x. So everything is good so far. If I need to figure out this dimension on the top right, well, what times x is equal to x? And that's 1. And now I go down to the bottom left and I ask myself the same question. What times x is equal to 7x? And it's 7. And just like with 2 by 2 grouping, what we finally do is we leave our last little box as a check. And if we use our last little box as a check, well, it turns out that 1 times 7 is not 12. Now what this tells me pictorially is I've chosen the wrong way of breaking apart 8x. 8x is equal to 1x plus 7x, but it will not give us the correct dimensions for this trinomial. So if I were going to guess and check again, well, I go to my next one. I go, okay, let's try 2x and let's try 6x, because x squared plus 2x plus 6x plus 12 is equal to x squared plus 8x plus 12. Again, I go through my logic. This has to be x, this has to be x. If this is x, this has to be 2. If this is x, this has to be 6. And I do my check mark, and 6 times 2 is 12. And given that my last piece works, I know now that x squared plus 8x plus 12 can be factored into its two pieces, and these two pieces are x plus 2, x plus 6. We have two binomials. And that's what we said above. In order to get a polynomial that has 4 terms, we multiply a binomial times a binomial, and normally, almost always, we collect like terms and make that polynomial into a trinomial. So then the question would be, wow, that would be a lot of work. This turned out to be my second choice. This would be a lot of work to guess and check, and guess and checking is not the way to go. So there's a little wrinkle in this. There's a little trick to figuring out how to break apart, or how to break apart that middle term. So here's our trick then. In order to factor trinomial, what we have to first do is we have to first break apart the middle term, just as I did above in the example. But what we have to do is we have to break it apart in an appropriate way. And we could do this by guessing and checking, but it takes too long, especially when the numbers are big. This is a really simple, straightforward problem. So then the question becomes, well, how do we do that? How do we break apart that middle term into two pieces in an appropriate way? So what I want you to notice in that example above is we broke 8x into 2x and 6x. And what I want you to notice is, I want you to notice that 2 and 6 add up to 8, add up to the middle term, but 2 and 6 also multiply to 12. So this is our little wrinkle. This is our way of making a trinomial into a polynomial that has 4 pieces, and if we can break it into a polynomial that has 4 pieces, then we can use the exact same factoring technique we learned last day. And the trick is, you want to break apart the middle term, so the coefficients add up to the middle term and they multiply to the last term. So what we're going to see as we go through some examples, we want two numbers that add. So if we go back to our general form, we want two numbers that add to b and multiply to C. So let's summarize our little recipe for factoring a trinomial by this decomposition method. That's the method I'm describing. We are decomposing the middle term. We are breaking apart the middle term. So the first thing we want to make sure is that we write the trinomial in a certain way, and we want to write it in descending powers of x. So this is the habit, descending. This is the habit I've asked you to get used to when we've multiplied and continuing on to unmultiply. Given we have it like that, what we want to do is we want to break apart the middle term into two pieces. Now these two pieces have to equal the original middle term. But they can't be any two pieces. The coefficients, the number in front of x of these two pieces, have to not only add up to the middle term, but they have to multiply to the last term. And when we do this little trick, you end up with a 2 by 2. And we are going to factor by 2 by 2 grouping. And the last thing that's always going to happen is we're going to write our answer, so the factors. We're going to write the answer as a product of binomials. So here's how we factor trinomials. A little bit tricky, but very, very, very important. Okay, so let me go through, again, two ways of doing it. If you know how to factor already, or you know another way, or you notice something fast, then you are always welcome to do it. The first thing in factoring a trinomial then, given that it is written in descending powers of x, is we have to figure out two numbers that add to 7 and multiply to 12. And the easier way to answer that is to actually look at the 12. So if we look at the number at the end of our trinomial, if we look for number pairs that multiply to 12, here they are right here. We could have went 6 and 2 and 12 and 1, but order doesn't matter. So here are the three number pairs that multiply to 12. And what I want you to notice, there will only ever be one pair of numbers that not only multiply to 12, but add to the middle term. And in this case, there it is right there. Now remember what this does. This breaks apart the 7 into two pieces. That's what this little trick does. And really what that does for us is it allows us to use this pictorial representation, or it allows us to do 2 by 2 grouping. And if we get the habit of x squared up in the top corner and numbers down in the bottom corner and like terms opposite, then what we can then go ahead and do is we can then go ahead and solve this pictorially. If that's an x, this has to be a plus 3. If this is an x on top, then this dimension has to be plus 7. And oops, sorry, that's supposed to be a plus 4. Then this has to be plus 4. And this last little thing is my checker, and 3 times 4 it is equal to 12. And I have factored this trinomial. If we were going to do this algebraically, if you still don't like my rectangles, well, you still have to do this same wrinkle, this little step. You have to break apart 7 in a special way. And the way we do that is we look at the last number, and we've asked the factors of 12 that add up to 7, and we do that, and then we break it apart. And what I hope you recognize right now algebraically is, wow, you have a question that we did in 2 by 2 grouping. And the way we approach this now is we break it into two groups of 2. We look at each piece individually. We use greatest common factor. And when we do our 2 by 2 grouping, what we do is we generate a common factor. So we are going to factor out the x plus 3 in brackets, and everything that is not highlighted goes in brackets. And if you look at that and you look at the dimensions of the rectangle, you'll notice they're exactly the same. So both of these methods are equally good. Let's look at another example. Now the only difference between this one is this one has a little negative right there. That is the only difference. I said in class, every factoring question is of equal difficulty. They're not hard, they're not easy, they're all the same. You just have to identify what you see and use an appropriate factoring technique. So our factoring pictorial technique right here is the x squared is going to go there, the 3 is going to go there, and what I need to know is I need to know what two x things go here. And the way I do that is I look at the last number and I figure out all of the factors that multiply to 3. Well, 1 times 3 is 3, but also note that negative 1 times negative 3 is also equal to 3, and this is my factor pair I want. These are the only two things that work, and if you've done it right, then one of them will be correct, and that's the one we've highlighted. Then we just go through our construction. This has to be negative 1, this has to be negative 3. The bottom one is my check to make sure I'm right, and negative 1 times negative 3 is positive 3. So I know that in factored form, this is equal to brackets x minus 1, brackets x minus 3. Let's do it algebraically. So we've done the same thing. We've decomposed, we've broken apart the middle term, and we end up with this. Now, I'm going to say that this is a harder algebra question. Negatives are tricky. So if we break apart this one, we end up with x minus 3. Okay, I want you to pause the video for a sec, and I want you to factor that last term. Okay, so you've gone ahead and factored the last term. And the thing that I hope you have factored out is, I hope you factored out a negative 1. So here's the tricky thing with algebra. If I broke this apart right here, I can write this as negative 1 times x plus 3. Well, that's not too useful because I don't see a common factor. But if I rewrote it like this, positive is a negative times a negative. If I rewrote it like this, you do have a common factor. You have this negative. And not only is it negative, we can disregard the negative 1. So if we factor out a negative from each one of these, the negative comes out. What's left over? Well, we have x minus 3. So that's a little bit of tricky algebra. Factoring out a negative 1 is a really, really, really important factoring technique, greatest common factor that is not always obvious. But what I want to point out is, in my pictorial approach, that never came into play. Anyway, what we've done algebraically is we have generated a common factor. I factor that out, and whatever is left over is my other piece, exactly as we have pictorially. Let's look at one last example. Again, same idea. I put my x squared stuff there, I put my number there, and I have to break apart the middle term. And in order to break apart the middle term, I look at the last term. What are the factors of 9? Well, the factors of 9 are 1 and 9, and 3 and 3. And if you wanted to keep going, it's negative 1 and negative 9 and negative 3 and negative 3. But when I do this, I generally stop when I have the answer I want. So we can break apart 6x 4 different ways, but only one of those ways multiplies to 9 and adds to 6. And what we end up with is 3x there and 3x there. Go ahead with our construction. This has to be a 3. X times what is 3x? That has to be a 3. And then we do our double check to make sure it's right. And 3 times 3 is 9. I'm confident I have the answer. So factoring this, the factored form of x squared plus 6x plus 9 is x plus 3 times x plus 3, or x plus 3 in brackets squared. Again, let's look at the algebra. We still have to break apart the middle term. There's no way of getting around it. We do our 2 by 2 grouping. I factor in x plus 3. I factor a 3, x plus 3. We've generated our common factor, and we factor that out, and whatever is not highlighted is our other one. And again, as I said, another way of writing that is x plus 3 squared.